Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University, and of course, in particular, the Observatory. I'll be one of your hosts this evening. I'm Dr. Elena Hyde, and I'm joined tonight by our reoccurring guest, Dr. Ali, broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. That's right. This 9th of September, we are getting all of the astronomy action. York Universe broadcasts every Monday night at 9 p.m. local Toronto time, except for holidays. That's Tuesday morning at about 2 a.m. UT, if that's more your speed. And if you're on YouTube, you will have noticed York Universe production works in concert with our online public viewing program. That's right, live images or archive images from the observatory taken by the observatory team, and it runs at exactly the same time, so 9 to 10 p.m. local Toronto time. And if you want to find out more about online public viewing or check our previous episodes, look at the archives, you can find out all that and more at yorku.ca/science/observatory and follow the links to either OPV online public viewing or perhaps the archive for York Universe and previous episodes. If you have questions, comments, or anything you'd like us to cover, please go ahead and send us an email at observe@yorku.ca. And if you're on the social media, any of the social medias, you can find us on Instagram at York U Observatory and Facebook at Ellen I. Carswell OBS. All of our programs are free, but if you'd like to make a donation, you can see that same website before I mentioned, yorku.ca/science/observatory, and the donation button is just a scroll down from the main page, just past the free event tickets. We have lots of crew monitoring the chat room over on OPV, and looks like the current weather is surprisingly cloudy. So right now we are showing the previously taken images, so not live, but still imaged with our very own telescopes, and our crew will be describing those to you over on YouTube. The clouds have been a little bit of a surprise. Dr. Ali, how's the weather where you are?
Oh, hello, hello. Not bad actually. It was raining like half an hour ago, almost
My
for a few
goodness.
minutes. Yeah, and now it stopped.
Yeah, we had a beautiful clear spot for about a half an hour, I think. um, I have heard those referred recently as sucker holes, where you take out all the telescopes and then have to put them away again. That seems to be what's happening at the moment. So clouds moving in, and I think that's it for live observing tonight. But tomorrow is always another possibility, so hopefully we get some more clearness moving in. And I'll just go ahead and take a little bit of a second to advertise that if folks are interested on that same website I mentioned before, we do have observers tools. So you can actually go ahead and find the weather out yourself. We've got a whole bunch of handy sites listed like Astrospheric and dark sky and a whole bunch of other ones. So if you are having trouble figuring out the best weather forecast, my advice is to open up several tabs and well, then you'll be doing it the astronomer way. So
Wonderful.
yeah, exactly.
Multitasking all the time.
Well, with weather, it is just unpredictable enough that you can be pretty sure you don't know what exactly it's going to do. So the more different sources you have giving you information, the better you can hope that they will reach some kind of consensus.
Exactly. Now, the
Um,
weather predictions are pretty hard, and
yes.
basically simulating the weather conditions is not so easy. So I'm not expecting one model to figure it out all. So yeah, I agree. Looking into many sources is better than just one.
Yeah, exactly. And actually, that's a good point. Different places that have weather predictions actually sometimes use different models. And specifically picking weather predictions that use different models will give you a better sense of whether or not they agree, which is why we have Astrospheric Clear Dark Sky, and windy.com, because they're quite different. So they all have show slightly different guesses as to what the weather will do. And if you really want to know exactly what's going on, of course, you just have to look outside and see what it is doing. See, the only way to know for sure.
Yeah, of course. I mean, seeing is believing.
Yes, exactly. And you definitely want to do that before you open your telescopes. I'm still actually seeing that Clear Dark Sky says it's clear when we can actually see clouds on the all sky camera. So you never know. And while you're out trying to get past the weather to do observing, it does bear a little bit of thinking about how much harder the earlier astronomers had it.
Oh, exactly. I mean, they didn't have even a proper dome, so they had to carry the telescope sometimes with them. And I mean, the rich one, of course, they had dome, but it was not automatic. They had to close it by hand and open it by hand. So it's much more complicated process.
Oh yeah, and of course, all these wonderful things we take for granted now in astronomy, automated tracking, so the telescope follows the stars, a warm room where you can observe and not be cold. All these things are very much modern inventions. And I think that actually gets us nicely over to a little bit of this week in space and astronomy history. So, speaking of olden times, we can go back in time a little bit for our history section. And this is the 9th of September, which I have trouble believing, but that's what my clock says. So, it's I think right now I'd be pretty comfortable with it being April. So, the fact that it's September makes sense. Um, let's go ahead and do a little time traveling. So we'll go ahead and go back to 1892. So this is September 9th, 2024. Going back past the 1900s all the way to the 1800s, we still had observatories in North America. And in particular, we had the Lick Observatory, which actually I was fortunate enough to be able to visit after they renovated. And on September 9th, 1892, so mm, quite some time ago, from a human standpoint, not so long ago astronomically, but for humans, this was a while ago. There was a whole observatory in North America over in California, the Lick Observatory, and Edward Emerson Barnard was one of the I suppose key observers. He was one of the most active observers, and he also did a lot of things that had never been done before. And it's pretty cool because, of course, whenever you have people inventing stuff, cool things can happen. He was incredibly, they say gifted, but I'll say skilled observational astronomer. He was using the technology of the 1800s, um, but at that time they did have early photography, and refractor telescopes. So these are not the beautiful, compact, mirror-based telescopes we have now. These are the big, long refractors that take a lot of space, and of course, are pretty hard to manage. And Lick Observatory still has this refractor on site that you can go see. So if you find yourself in San Jose, California, I highly recommend it. The refractor design of telescopes means that this telescope is incredibly long. It is an absolute beast, and it's not the largest aperture telescope, but it had a 36-inch or 91 centimeter lens. So it's smaller than the 61 centimeter and the 1 meter telescopes that we have at York, but it's a refractor, which means it's incredibly long. And it goes up probably the equivalent of 8 stories or something. It's an incredible construction, and the gears that they have to run it are have been upgraded over the years, but there's a lot of manual controls there. So you'll see things like cranks where you can hand crank the ladder to match up to the side of the telescope, and all kinds of fun stuff. And in 1892, Edward Emerson Barnard, or E. E. Barnard, was up there observing away, and he was a legendarily uh, accomplished observer. He was able to tease out things that other astronomers just were not able to find, things that were incredibly dim, things that were incredibly fast moving, and he has a lot of accomplishments to his name because he was at a observatory, and he was one of the best, if not the best at the time. He's the one who discovered on this day in history, and so this is why it's today, not tomorrow, September 9th, uh, Jupiter 5, or Jupiter's fifth moon, Almathea. And if you go back to old sci-fi written in the early 1900s, they all call it Jupiter 5. Um, but Almathea is a pretty small moon. It's not anywhere near as bright as the four Galilean moons. So Galileo obviously was able to map out four of the moons, which at the time was a new record. I think the Chinese had three. And yeah, he was able to find this incredibly much smaller Almathea, and he then discovered a Himalaya, which in 1904, photographically, as opposed to just with your eyepiece. And he had incredibly good skills at not just doing the observation, but processing the photographic plates. And apparently, he actually started this whole career from the age of 9 years old, because at that time there was no limit as to how young somebody could start working. So he worked his way up as an assistant photographer starting at about the age of 9. Something, child labor in the 1800s. But he did become one, or arguably maybe the best observational astronomer of his day.
Maybe
And
that's the reason he started really early, and people
yeah,
learn and become skillful at very young age. I know
he did
he's
start,
named.
yeah.
I know there's a dark nebula named after him,
Yes.
Barnard 68. I suppose there should be a lot more, but Barnard
Oh,
68 is a famous one, and he
yeah,
has a
there's a
catalog
whole,
of dark nebulae.
absolutely. And he was incredibly accomplished. He does have his own catalog, so you can look it up, Barnard's catalog. And he has a few really famous objects that he's discovered that, of course, got him a lot of fame. Of course, Amalthea, moon of Jupiter, and low surface brightness objects such as small, tiny little rocks that are really hard to see. These call for long exposures. And back in the 1800s, you needed to set up exposures of 2, 5, or even 10 hours long. And from the beginning to the end of the exposure, that whole 2, 5, or 10 hours, you had to guide the camera, and keep a constant watch on the star out of the dome, not in a warm room. You were up the ladder, outside, in the cold, making minute, tiny adjustments in the dark to keep this dim star centered on a pair of crosshairs in the eyepiece for 10 hours at a time. And
That is
then
impressive.
yeah, and then of course, if it's a photographic plate, you'd have to do a whole long process to get the plate carefully extracted, take it to a dark room, develop it. The quality that he was able to produce is still astonishing, and it's a testament not only to his skill, but also like physical endurance, because this was an incredibly challenging task. It was technical, It was precise, and in some cases it took a very long time.
I agree. I
Almathea,
agree.
yeah, it's
But they had a beautiful night. I mean, no light pollutions at all. I mean, barely there was any cars or lights like what
yeah,
we have
the
now.
the
So it
skies
was
were substantially better in California when this observing was going on.
so
They
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 had
did still have
motivations.
light pollution from some of the nearby towns because of course California had the gold rush, so they had, San Jose was a fairly big town, but it's nothing compared to what it is now. So yeah, you would have had much better skies.
They had big motivations, right? The beautiful sky attracts them all the time.
Exactly. And it's, Almathea was the one that happened on this day, but it's definitely not even his most famous. I think most people will have heard of Barnard's star, which is a high proper motion and very famous as pretty much the highest proper motion star that's out there. It's really zipping across the sky. And as you said, there's a whole catalog of amazing objects. And fortunately, he also did this little tiny moon as well. So he was the one who got to do the discovery. And Almathea is actually a pretty interesting moon. He was able to find out a bunch of properties of it over time. And of course, once he announced the discovery, lots of other people started observing it as well. Almathea actually has the third closest orbit around Jupiter, and it was the fifth moon to be discovered, so it can also be called Jupiter 5. But it's also the fifth largest. But it's the moons of Jupiter, the Galilean moons, are substantial, and then after that, it's a big reduction down to Almathea. So Almathea is about 1/19th the size of Io. It's tiny. It's so small that it doesn't circularize. So it basically looks like a kind of a strange space
Potato
potato.
shape.
Yeah, potato shaped. And its tiny diameter protects it from tidal heating because it goes within Io's orbit. So it actually gets closer to Jupiter. And it's got this weird shape, it's got this weird orbit, it's got this tiny size, and it's actually the reddest object in the entire solar system. And there's still some debate about why that is. So, since Almathea is so close to Jupiter, we think that eventually it will decay and fall in. But it hasn't yet, and it continues to be kind of a little mystery here in 2024, many years after it was discovered.
Do we know how this moon was added to the Jupiter? Is it an asteroid captured by the Jupiter, or was it? Or, I don't know. I mean, is it part of the used to be part of the Jupiter, or is it captured?
Well, we think that it could have been, but there's not really a good consensus on whether or not it was captured. The thing is, Jupiter attracts a lot because it's so massive, and Almathea, they're not even sure if it is completely solid. There the density is so low. It they think it actually might be some sort of um, partly icy or a rubble pile, like a collection of smaller things that have sort of been glued together with ices, which means it could have been something that was, from the asteroid build. It could have been, captured. It definitely probably did not form where it is, which is, in this strange orbit that brings it very close to Jupiter, because that's not stable. So it's probable that it formed probably farther away from the sun than Jupiter, maybe out in the icy outer solar system, maybe out past Saturn. It has, a lot of minerals, and a lot of minerals that are water adjacent or containing water like elements. So they do know a little bit about it because it's been observed so often. And there's some pictures, not incredibly high resolution pictures, but you can see it's really red. And one of the things that people have been wondering is why is it so red? What's making it so incredibly red? Is it getting some sort of special treatment by the radiation belts of Jupiter? Is it interacting with something? But we don't know. We've never actually been there. We've had some, as I say, some reasonably good pictures, but nothing as high resolution as what we have for, of course, the Galilean satellites.
Of course. Now, while we are on the concept of astrophotography, uh, let me go a little back in time, like about maybe 40, 50 years back in 1839, when John Herschel, for the first time, photographed the moon. Of course, photography and astrophotography was very new, perhaps maybe less than, in general, photography was new, maybe less than 100 years, but astrophotography was flourishing at this time. So John Herschel, the famous son of William Herschel, the famous scientist who discovered Uranus in 1781, he followed his father, become an astronomer, mathematician, a chemist, and he spent a lot of his time discovering new ideas and new things. And one of them is, for the first time, using astrophotography to picture the moon and its details. Now, it is also interesting to recall that John Herschel is the one who termed the photography, I mean, coined the term of photography, and also he's the first one to basically use the term negative and positive in photography. So he worked significantly on creating catalogs and using new this creating new different devices, but I thought maybe this is nice to remember John Herschel for his first photography of the moon. So
Oh,
if you want to,
absolutely. Yeah, it says, and I mean, of course, those photos are pretty awesome, and that was a little bit before the daguerreotype, I believe.
yeah, and this kind of photography was a little different from the kind we know. It was on glasses and it was more like chemistry. You had to come up with, you know, compounds and elements which are sensitive to light and they can be, you know, put them on the glass and then basically stick them to the glass somehow. So it was a very, very advanced process to create photography plates and then use them for astronomy. And they managed to discover many of them. And of course, there was black and white at the start.
Yeah, well, there was the Herschel. I think, yeah, he was the one who also did the cyanotype, which is blue. And this was, as you say, a result of mixing various chemicals with optics to investigate this, new art of photography. And how do you fix a photographic image? Because you want it to stay on a plate or something afterwards. And he discovered a chemical fixer that would develop quote unquote film, but he also created the cyanotype, which is still used today or at least it's why blueprints are blue. So it was the basics for all these architectural blueprints, which I think they're now not done by cyanotype, but that's how that came about.
Yeah, I guess the
Uh,
name was coined because of that.
yeah,
You're right.
exactly. And it's really interesting because of course, he's experimenting with all these chemicals and optics. And I did hear a rumor that he was actually the one who coined the word snapshot.
Oh, I didn't know that. That's interesting.
Yeah,
A snapshot.
snapshot.
Nice.
Um,
Well, when
so
you think
taking,
about it, it's really hard actually to come up with a new name for things. So it is really time consuming to come up with a name like a snapshot.
yeah, I wasn't able to find the publication for that, but I did find that he actually has a paper out on the art of photography or the application of the chemical rays of light to the purpose of pictorial presentation.
Very technical.
So if you go to that paper from the Royal Society, this is the words photography, emulsion, positive and negative will all appear. And of course, there's some beautiful blue pictures that he came out with, including, I think, one of the only pictures of the telescope of the Herschels and the wooden
Perhaps.
frame that they had out. Um,
Yeah, and of course, I mean, the best or the first image of the moon.
yes, yes, which is not to be underestimated at all.
Well, it's
It's
not as good as traveling to moon, of course, but I mean, having the first image of the moon is as good as traveling to moon.
It's yeah, and it's it's a moment of history, It's we can see the moon as Herschel saw it, which is pretty cool. And the moon, I think the moon photography wasn't cyanotype, wasn't that was a different one. That was like calotype or something, right?
Yeah, it is some kind of brownish color, so
Yeah.
definitely couldn't be cyano.
Yeah, I think that's calotype instead of cyanotype. But like I said, he was playing around with so many things, right? I don't remember. Calotype uses something else, but it does turn out brown. So that's probably what it was.
Kind of orangish, brownish. The photo I saw was kind of orangish, brownish.
Yeah, that's definitely a calotype. And I've seen the one of the moon as well. And of course, being able to pick out lots and lots of details on the moon was still a pretty new endeavor, because you could see really good details in the craters and stuff. So excellent.
But one of the good things about those old-fashioned photography and these glass photos is the resolution of the image was proportional to the size of these element or crystals they use, and they could make it extremely small. So the resolution was extremely high. The
Yes.
images had a lot of details. In opposite to what we have now, the size of the elements in a CCD camera, of course, is in the size of the micrometers, but it's still much bigger than the size of the crystals in those chemicals. And so the quality of the images created in the past, to some degree, you can say it's much higher than a normal CCD cameras that we use.
Yeah, and that's why, the Palomar plate surveys are still so popular. Um, People are, they digitized them so that they can be scannable, but they're wonderful resources, these old photographic plates. But that said, they are very hard to deal with. And it is much harder to tease out exact astronomical measurements from a photographic plate than it is a CCD.
Oh, because it's not linear.
Exactly.
Yeah, so it makes
Um,
it really hard to convert it to number.
yeah,
Okay,
so
so it makes
you
sense.
get pluses and minuses.
Yeah, I can
But yeah.
imagine. But at least discovery should be the same. You should be able to notice if something is significantly brighter, like, for example, supernovas or novae could be
Oh
easily
yeah.
identified.
Well, and I mean, all of the early astronomical catalog work was done off of these plates, so
Yeah,
they're quite good for many things. But in terms of repeatable, measurable quantities, CCDs do behave in a much more linear fashion, and at least if they're nonlinear, they tell you by how much because you can you can measure that.
yeah, you can control
Uh,
everything. So, yeah.
but yeah, very fun, and the moon is, of course, always a fun target.
Oh, moon is always fascinating. So you can read about moon all the time. I mean, about visiting moon, traveling to moon. I got a ticket to travel to moon with Artemis. Of course, it's not a real ticket, but you can put your name on one of these tickets. I have one ticket to
Yeah,
moon, one ticket to Mars, so but I didn't go to them.
I have two tickets to Mars, but that's all. I forgot about getting the ticket to the moon. But that's a good point. Is you can a lot of times these missions they have little options where you can sort of sign up to have your name engraved in like really 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 tiny little letters on some part of the craft or something, and then they take it with you. Which is always fun. And of course, the moon having lots of good history, I might just take us to our next story.
Yeah, what is the next story then?
Well, speaking of the moon, boy, this next one is exciting. So, when you think about the moon, you don't often think about sort of action movie fight scenes. However,
You mean with
um,
aliens?
sort of, in 2002, on September 9th, there was a pretty famous moon related fight scene between the astronaut Buzz Aldrin, who was at the time 72. He is now still alive and 94, by the way. So Buzz Aldrin, in 2002, at the age of 72, gave a very good punch to a particularly persistent moon landing denier. And this is a an interesting moment in history, but it is worth noting that, of course, the person who when this happened, the person who was trying to provoke a reaction was a Mr. Bart Sibrel, who was a particularly famous moon landing denier, who was really going out of his way to antagonize and harass people, and to this extent of stalking them and being very aggressive and pushing them and demanding they swear on the Bible. And Buzz Aldrin in 2002 was just, arriving at a hotel in Beverly Hills, where he was set to give an interview for a Japanese educational program, and his stepdaughter was with him. So of course, this guy comes up and starts pushing them and being aggressive, and it gets on camera, and there's a short video. And Aldrin tries to be polite, um, but then, of course, this fellow starts calling him a coward and a liar, and I believe then pushes him, and yeah, gets punched by an astronaut. And of course, due to the fact that it was recorded and there were many witnesses, um, there was no charges filed against Buzz Aldrin for this. Um, I believe the quote was that the witnesses all stated that Sibrel provoked Aldrin by aggressively poking him with a Bible, which is very for a moon landing hoax proponent, very on brand, I have to say. But he unfortunately, Sibrel did go on to harass quite a few more people. Um, but um, but the notoriety around it actually really helped remove a lot of doubt, because moon landing proofs are abundant, and showing having this happen in 2002 did fortunately sort of, shall I say, amplify the conversation around the many proofs for moon landing that you can see for yourself. Any human here on Earth can see these proofs. So I thought, in honor of the 2002 Buzz Aldrin moon landing denier punch, we would
That's a
just go.
nice name. Lander
Um,
Punch.
yeah, I mean, and obviously this was provoked. He wasn't. I mean, you shouldn't punch people for no reason. But if they're gonna start poking you and pushing you and calling you names at some point, yeah, I don't have any problem with this one. So I thought, in honor of this event, what we could do is maybe just share with our listeners tonight some of the moon landing proofs, and this is not all, but some that you can easily see for yourself. So first and foremost, we have on Earth the pieces of the moon that were brought back by the astronauts. They are very clearly unlike what we can find on our own planet. Throughout the 6 different Apollo missions, NASA astronauts brought back about 842 pounds of moon rocks for scientists to study, the oldest of which are about 4.5 billion years old, or 200 million years older than Earth's oldest rocks, which are in Australia. And of course, we have lots and lots of analysis and experiments that have shown over and over these are just not the kind of rocks you can collect on Earth. You
And this
cannot find
happened,
them.
and this happened when we didn't have robots to walk around the moon and collect and bring back. So it was
Yeah.
done by the humans.
Yeah, the humans walked around and collected these rocks and brought them back, and they're on Earth. You can go see them, and they you can learn geology and verify for yourself that they are almost completely void of what we call volatiles. These are chemical elements and compounds with low boiling points found in almost all Earth rocks, terrestrial crust, and atmosphere. This is nitrogen, carbon dioxide, water, hydrated materials. Moon rocks do not exist on modern day Earth. So you can actually, go and look at rocks, or if you want to, you don't even have to put in that much effort. Even today, you can, if you have a telescope, or if you want to come see through the 1 meter telescope at York, you can spot the landing sites for the Apollo missions on the surface of the moon. And you don't even have to do it yourself with your own telescope. Images collected by NASA's Lunar Reconnaissance Orbiter, or LRO, actually published in that was back in 2011. They very clearly show the touchdown landing points of Apollo's 12, 14, and 17 lunar landers. And of course, the astronauts made their way to the ground and they walked around the surface. And you can see that in the Lunar Reconnaissance Orbit images. And of course, we have lots of additional images that have been published since then. We also have images from lunar rovers more recently that have seen what the astronauts saw. So we know that the images that the astronauts sent back are true images of the moon because the exact same landscapes and scenes captured by the Apollo astronauts have also been captured in recent years by the robots that we have now, the rovers that we have now, and the rovers that we've sent to the lunar surface. Japan's Selene or Cayuga orbiter has been able to get images very recently, which have um, uh, shown the base of what's called the Apennine Mountains, which were also photographed in Apollo 15. And not to go through all the possible things that you can do, but if all of that didn't convince you, you could also look at what is one of probably the most famous examples, the laser ranging retroreflectors. These are LRRRs. These are special mirrors that are actually still used, some of them, as targets for Earth-based lasers. And we have lasers on Earth that shoot up at the moon. They reflect off of these retroreflectors, and they come back to Earth, and we measure the time it takes. And this is part of NASA's lunar laser ranging experiments conducted during the Apollo program. And basically, once it hits that reflector on the moon and bounces back to Earth, we can measure the exact distance between the Earth and the moon very, very accurately. And we can find out that the moon is slowly spiraling away from Earth at about 3.8 centimeters per year. And we can do all kinds of fun things. So the lunar ranging retroreflectors, which is a bit of a tongue twister, are one of the things that you can actually see at work if you want to go find one of the lasers that's currently shooting at them to do the distance measurements. And these, experiments that we're doing could only be made possible by having these reflectors on the lunar surface. So all of this and more are, reasons why we can see it happen. So
And if they don't believe that, still, they can go ask our enemies. They can go ask the Russians, the Chinese, everyone
yeah,
who visited Moon. They can confess that, yeah, there is evidences here. And if that is still not convincing, I suggest nominate yourself, buy a ticket, and visit the moon. That's even a better proof for you.
Yeah, that will become a definite possibility once we have Artemis, if it does go ahead, which it's, it is still scheduled. But of course, we are looking at more and more interest in the moon from all kinds of space agencies and private and of course government. So NASA with Artemis's plan to land on the moon. And I believe they're still saying 2025 for the next section of Artemis, but I am expecting it to get blown out a little bit from that. So, Artemis 2, which is the next step, will be a crewed test flight around the moon. So you can go on that if you want to try to apply for Artemis 2025. And then
Exactly.
after that, you got Artemis 3, which is still set for 2026, which I'm a little surprised by. So we'll see. And of course, if you we are looking at private missions being very popular. Actually, just a little shout out to the news section later. SpaceX is launching another private space astronaut mission tomorrow on September 10th for Polaris Dawn. So, if you have the millions of dollars, you can just go into space and look for yourself.
Yeah. Now, I understand why people are skeptics, and this is part of the science. We always evaluate and reevaluate what we discover and what we see and what we understand. But that doesn't mean that we start with a denying and then we stick to it when we never change it. For example, similar thing happens, I mean, not in that scale, but long time ago in 1975 when Viking mission launched and sat on the surface of the Mars. The goal was to discover and explore the Mars and, of course, looking for evidences for life. And surprisingly, this NASA Viking 2, which was specialized and it was equipped with a lot of instruments to investigate the soil, the weather, the temperature, mapping the surface, and finally looking for biological evidences, it actually reported some evidences for it reported initially a basically observation presence of some microbial life on the surface of the Mars. Now, initially everyone get excited, and then because we do science, we need better and more objective proof. And so they started reviewing the results and over, and eventually it was technically ruled out as a false positive result. And so this is very common that we don't accept everything initially, but that doesn't mean that it's impossible to, for example, go to the moon. We know we went to moon, we can go again. There was no motivations at the time or after that. But now, again, we are back to the race and we want to go this time, create a real station's long-term presence on the surface of the moon. So,
Oh yeah, it's going to be so fun. And as you say, it's one of the things is the great thing about science and the scientific parts of it, it's verifiable and reproducible. So if you don't believe us, you can go and try this yourself.
exactly.
And
So,
if you find something new, tell us. We'd love to know about it.
oh, definitely. Aliens. I mean, sometimes they think that we don't want alien or we don't like alien. Scientists love aliens more than anything else. But the problem is we rely on evidence. Speculations is fine, and imagination is good, but we need evidence to rely on something. And so until the evidence is objective, until it's reproducible, we hold our basic excitement.
Yeah, exactly. It's that's the difference between a fun sort of science fiction theoretical crossover and something you'd want to publish, right?
Yeah, exactly.
And that's what we want to hold the verification for proof at a very high bar. And as you say, the Martian search for life, because the bar for proof is high, it's really, really hard to do remotely on this extremely sort of dry, hazardous surface when we don't have active, uh, large life forms running around that we can take pictures of. So we have to try to do other types of detections that are a lot harder, and that's, I guess, as you say, the microbial life. That's a hard detection to make. If you had big giant sample containers and you could bring it to a real proper lab here on Earth, you could really rule out any false positives and make a very good detection of whether it's microbial or not. But if you're just a little tiny rover and you're all the way on Mars, you're limited in what you can do. And I think that's one of the things that sort of caught them out a little bit with the Viking program is that it wasn't an overwhelmingly positive detection in any means, and so it's like, well, we just can't say that it's there because we don't see it convincingly, and that's good because that means that the scientific method part is working, but it's frustrating because everybody wants to find life on Mars.
Yeah, exactly. I mean, we are looking for it, but we are not going to fool ourselves with evidences or things which we know it's not reliable. So another reason, and another example is the discovery of methane on the Mars. Now, methane can be produced from many sources, geological sources, and normal chemical reactions. It's true that methane comes from life stocks, mostly on planet Earth, but it also can be generated through volcanic activities and other processes. And so when they detected methane release on the surface of the Mars, yeah, the first step was assuming that maybe this is because of the microbial life. But then when they studied again and again, the reason to believe that this is from microbial life was gone. And so now, still, we are on the same page. We don't know if the sources of the methane is life.
Yeah, exactly. And it's without convincing proof, you can't say one way or another. But I would say that, with the current efforts for sample return, and of course, plans to actually go there and set up some sort of human base, if that happens, then your answers will get a lot better.
Yeah, of course, when we get there, we have contaminated the entire planet and we become the source of life on that planet. I'm
We
hoping that happens.
we become one of the sources of life. That's
One of the
and
sources.
yeah. And that is another problem is that it's not a even if you're building habitats and your humans are staying inside, how well are you really contained? A little hard to say. And you wouldn't want to interfere with life that was there. So, knowing if there is a lot of microbial life would be a good thing. I hope they get that sample return working.
Well, there is two camps on this. Some people like actually to see bacterial life or microbial life similar to the planet Earth. Some others they prefer to see something completely different, something unknown. And both have basically their own arguments. Some claim that if we find something different from us, that means, and they are basically extinct, that means there is a big danger in front of us. We don't know it. We don't know what it is. And we might actually go extinct as well. And the other camp has a different argument, but it's a very complicated situation, both theoretically and experimentally. But any form of life is interesting.
Oh yeah, absolutely. And I mean, the one thing we can say pretty definitively is, we now have enough consistent images of Mars's surface that we can pretty much say that we're almost completely certain there's no large life on the surface, right? So at least we've ruled that out.
Perhaps.
But we don't know very much at all about what's going on underneath Mars. Even now, they're finding more and more evidence for subsurface water and interesting things happening. And it's like, oh, there could be so much going on just, in some of these caves and lava tubes. But Uh, we should probably get to the news section before we get too distracted.
True.
Um, I'll
So
just I'll just give a little shout out on our way to the news section. I had it in there as optional, but a little bit of fun if you are going back to in this day in history. On the 12th of September in 1940, that's when they found the Lascaux cave paintings, which do have a star map thought to be about 16,500 years old. A little bit of a reminder for the Allan Carswell Observatory, we do have an atrium tour this Wednesday, weather allowing. So if you have tickets, make sure to check the weather before you go. If it is cloudy or raining, we will not be able to go ahead because the atrium tours are outside. Also, because our 2025 calendars are coming out soon, the 2024 calendars are now on sale for only $5 for any in-person sales. A huge discount. Pick up some fun images for the rest of the year. And watch out for those 2025 calendars, which will be coming on sale soon, I hope. Now, for the news, since we've been all over moons recently, let me just tell you a little bit about the latest news for the moon. We've seen all kinds of things happen with the moon. We've seen water detections. We have Artemis planning to go to the moon, as we mentioned before. But China's Chang'e 5 sample return probe, which brought back a little piece of the moon, and it landed in Inner Mongolia back in 2020, so not that long ago. That's 4 years ago. Um, and it has some pieces that seem to indicate some kind of, maybe not recent for humans, but geologically recent volcanic activity. So they have, again, evidence, and this is not proof, that the moon may have had some sort of volcanic activity or eruption just 120 million years ago. So a long, long time ago for anything human related, but not billions of years, hundreds of millions. So,
it's very
um,
recent in the scale of astronomy.
yeah, and it's
Technically
more
yesterday.
recent. It's more recent than we would have thought for the moon, by the most part. A lot of the volcanic plains actually do go back to about 3.8 billion years. So they're very, very old. And it's thought that most of the moon's volcanism, most of the lava, most of the heat went away very quickly. And this is billions of years ago. But what Chang'e 5 brought back in terms of the rocks that they selected, um, it shows that there are little glass beads in the rocks, and only 3 out of 3,000 uh, um, pieces had these glass beads. So they basically searched, very, very carefully the 1.7 grams of lunar dirt for these needles in a haystack, and the beads are very small, so they're 20 to 400 microns in size, and they can be formed by asteroid impact, so it could be impacts, melting and pressurizing rock, so it turns to glass. It can also be formed volcanically, so magma fountains produce volcanic glasses, and that has previously been found in samples of the moon's surface. But the fact that they found this landing site in an area rich in volcanic domes, and they managed to find these three glass beads, basically let them estimate that it could have been as early as 120 million years ago. And so, more interesting results from the near the volcanic domes, which is also where they had those lava tubes. So, really cool stuff happening on the moon right now.
Interesting. So technically, we have to assume that this was created maybe by a mixture of a collision with the surface of the moon, and then after that, lava is coming out, maybe.
Yeah,
Um,
there's a bunch of different ways you could probably make a case for it, and it is tentative, but it's interesting. So the facts are that they found some of these glass beads in the rocks, and there's a bunch of potential explanations that could have been just a magma eruption or a magma eruption sort of caused by an impact, or you know, depending on what the rest of this volcanic dome region shows, it could actually be just a last remnant of volcanic activity.
very early, very recent. Interesting.
So I think we have time for one more news article, which is good because that's all we have. So
Oh, okay. So
I
we
want to
can
make
talk
sure
about
I want to make sure we get this one because it's like a now for something a little bit different. Um, you've got a really fun one.
a little different, but also it's related to the imaging process because in on September 7th, 2024, just a few days ago, James Webb released a new image, extremely high resolution image of a galaxy, and a spiral galaxy with arms, stars, and so much details. We have never seen anything like it before. Now, why such an image is so important? Because when you want to understand the evolution of the universe, you need to understand the evolution and the structure of its components, which are the galaxies. And galaxies are extremely far away from us. And the resolution of the telescopes we had so far was not enough to see every single stars within the galaxies. Now, this James Webb Space Telescope image, which is in infrared and mid-infrared, the resolution is so high that you can see some of the most amazing details. And astronomers believe that by studying these kind of images, which they are hoping James Webb creates more often now, they can study the process behind the star formations, the distribution of these dust, which we believe should be plenty within the galaxies and between the galaxies, and also to understand even the evolution of these galaxies. So I think this is going to start a new era for high resolution image processing and also more precise astronomy of high redshift. I mean, so far at this moment, when we study the universe and the galaxies at a very high redshift, the errors are large, something around 10%, 20%, sometimes even 30% error. Now, these kind of images can help us to actually bring these errors to maybe 1 or 2%. And so precision astronomy now become possible even at early universe. And so I'm extremely excited about this news. What do you think?
Oh yeah, and I mean you're absolutely right. It is a nice way to go back and emphasize the photography. So I encourage everybody to go and click on the webtelescope.org and actually zoom in on NGC 628 or one of the other any other galaxy image you like, and you'll note how beautifully this image is processed. We have a beautifully clear image. If I was to download the science data, I could download multiple different channels showing the near cam part, the mid-infrared part, maybe even optical overlays. I could download all of that on my computer and have, as I say, CCD images, which are quantifiable, measurable, and provide a tremendous accuracy for beautiful high resolution galaxies. And if you compare the process of me going to the website and clicking download with the first processes we were talking about, the early astrophotography, it is it's amazing now where we start the astronomy because we're starting astronomy with images that are already cleaned, already processed, already don't need to be developed. The colors have already been balanced, usually calibrated, and we now get to do science. We get to do data science, we get to do analytics, we get to do statistics, and we don't have to spend 10 hours watching it through an eyepiece to even start collecting the data that then has to go on a photographic plate, and a week of really hard work later, you get out a measurement, right? So it just
Exactly.
goes to show we're so spoiled now, and I love it.
Exactly. I mean, I remember we used to tell students that almost everything you see and it looks like a star when you are looking at a galaxy, these are typically a globular clusters of stars, like hundreds of thousands of stars. They appear to you as one single star. But now, when you look at these images, there is a possibility to see maybe one single star in another galaxy millions of light years away. And that's astonishing. And now you can see the gas between the stars and how they are fragmented and how they are forming. This is going to be a revolution, a new era for studying the galaxies and the universe. I'm extremely excited about this.
Oh, absolutely. I'll join you on that optimistic and excited note and hope that we poor ground-based astronomers get some more clear skies. Well, everyone, you have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Dr. Ali and myself, Dr. Lena Hyde. And you can always connect with us on Instagram or Facebook. And of course, check out our website for show notes, content updates, and contact info and that donate button over on yorku.ca/science/observatory. Thanks for tuning in to York Universe, Clear Skies, and